Good afternoon. Welcome to this session number 317. And in this session, I will try to replicate the solution for the last two problems that I tried to resolve before. The first is the construct binary tree from in order and post order transversal, and the other is the revealed cards in increased order. Yeah, these are the both or the last problems that I can't resolve for myself. I studied the solution and I would like to try to validate if works. Okay, and this is the idea. I will not submit. Yeah, I only want to check if I can replicate the solution and validate if I really understand the solution, and check if I really learn how resolve it. Well, the first problem is this construct binary tree from in order and post order transversal. Given two integer arrays in order and post order, where in order is an in order transversal of a binary tree, and the post order is the post order transversal of the same tree. Construct and return the binary tree. Yeah, well, basically you have two arrays that is the output of the tree, in this case this tree, but in different order. In order is like this, for example, is 9, 3, next to is 15, 20 is 7, yeah, and the post order is basically 9, 15, 7, 20, and 3. And with this information we should return this. That is the binary tree. Yeah. Now, for resolve this problem, let me copy this and move here. Increase the size of this. Okay, I think that it's okay with this. Okay, now okay, here the idea with this problem is that first understand how works. Yeah, what is the behavior or in order and post order. Okay. Next to the first point is that we can check or we can detect that the last element in the post order is the root. Yeah, is the root of these elements. Yeah, for example, the 3 basically is the root. And next to, we should ask in this array only in having the reference, yeah, or pointers left and right. Is basically this substring. The first time is all the array, but for example, in this substring, where is this number? The number is here. Yeah, okay. These elements are in the left side, and these elements of this subarray is for the right right tree. Okay, 15, 20, and 7. Yeah, and for know in which position is this element in the array without transversal many times this array, basically we need mapping these values. Okay. Yeah, basically here the 9 appear in the index 0, 3, 4, 5, think that it's enough with this. 15, 20, and 7. Yeah, if this is not necessary. This. Okay, and for example, in this case, okay, the tree in which position is in the index 1. Yeah, in this case, we know that this is the subtree in the left side, and this is in the right side. Yeah, and now this is moved one time, or is removed. Now it's moved right to left. Yeah, in this case we are here. Now the 20 in this case is in this subarray, and the array is between this and this. In this case, the 20 appear in the tree. Yeah. Yeah. 0, 1, 2, 3. And in this case, we can say that the 15 is in this side, and the 7 is in this side. Yeah. Now, for the tech, where it's necessary, for example, if you have a tree like this, yeah, how know that here is null because doesn't exist? Well, basically when L is greater than R, yeah, when the index of the L appear after that the R, yeah, and yeah, basically this is the solution, and this is moved one by one by one by one. Yeah. Now okay. Oh, sorry, I don't share the link here. Okay, now okay, now we should okay. The first is create the map that help us to map integer map. Here is map, it's equal new hash map, and next to it's a for that integer I it's equal 0, meanwhile I it's minor 2 in order dot length I plus plus, and next to is map dot put, and is in order in the index I, and where is the index, in this case the I. Yeah, and that's it. With this we can make any query, yeah, without transversal the in order array many times. Yeah, next to is create this function build node, build tree. Yeah, and this basically is a function that return a tree node, but this function receive the index L. Even let me create here the L, it's equal 0, integer right it's equal in order dot length less 1 L and R, and we can avoid to pass this as a parameter, create these arrays in this point, but with the extra word copy. Yeah, and basically here is okay, this it's equal to this, and post order copy it's equal post or this is with lowercase letter. Yeah, post order copy, blah, blah, okay. And now this function should return tree node. In this case is a private tree node because return this build tree that receive integer L, integer right. Okay, and next to is the first validation is when L it's greater than R, return null. Yeah, is when don't have elements in the left. Yeah, and in this case it's curious because what is the comment? In one comment mentioned in this, and it's important because in this case we start with the build process with the right side, not with the left, and it's because in the post order is left, right, and root. Let me check what is the comment. Here, post order left, right, and root, and in order is left, root, and right. Yeah, we are building in this way: right, root, and left. Okay, here, and okay, we need an no index it's equal no index, and this index we need a pointer that is used for the post order and starting the final and move right to left until reach the 0. Yeah, this is equal post order dot length less 1. Yeah, this is important. Why is important? Because here basically we get the value of the root. In this case is root value it's equal post order in the index yeah, and next to is create tree node it's equal tree node and the value of root value. Yeah, now next that is create the right side. Yeah, now for this is basically node.left it's equal build tree, but in this case do you remember that we, for example, this is here but one moment, we okay, this is the root. Now is get the index. We need the index, the index of the this element, the tree, here. Yeah, for determine which is the left subarray in the left side and subarray in the right side. Yeah, and for this is this point. In this case is integer index. No, index no. In pivot it's equal map.get, in this case the root value. Yeah, and with this we are now that the left side is basically between L and pivot, sorry, here is pivot less 1. Yeah, why less 1? Because we are here, this is pivot, is basically okay this less 1 until here. Yeah, that is basically a single number. And in this case is between pivot plus 1 until reach, or the subarray is between pivot less 1 until the error. And now here is index less, and here is return node. Okay, and post order. It's post order copy. Sorry, post order copy. New. What? Ah. Okay, now what is happening? Happen right now happened that the result is Stack Overflow. Mm-hmm. We get the value is in the last. Okay, and we create the node. Okay, we get the value, root value. For example, this case is the 3, return 1, and it's between L and pivot less 1. I think it's for sorry. Okay. Map.get. What is wrong here? Right. This is wrong. This is pivot plus 1 to root value. Something is happening here. wrong. Okay, let me check because I don't know. L it's for and R is for 0, 1, 2, 3, 4. Okay, and we get the value of index is the last, means that the tree should be returned 0, 1. Root value should be 1. Now root value, yeah, it's the tree. Here is put the tree, and next to this pivot should be 1. Is pivot plus 1 until reach this. Now the next that is 20. The 20 is here 0, 1, 2. Why return 1? It's 20. Root value yeah is here. I will not solve with this solution because I would like to try in a few weeks, but I would like to check if works with this test. So order is this. Now the next that is this. Next to is this, and the last is this, and this is the super array. Okay, I think that it's enough with this, but until now works. Okay, I will try in a few days or weeks maybe. Okay, now I will try to replicate and yeah, do the same that the previous problem, but now with this that is rebuild car in increasing order. In this case is you are given an integer array deck. There is a deck of the cars where every car has a unique integer. The integer on the ith car is the deck in the index I. You can order the deck in any order you want. Initially, all the cards start face down, unrevealed in one deck. You will do the following step repeatedly until all the cards are revealed. Take the top of the card of the deck, reveal it, and take it off of the deck. If there are still cards in the deck, then put in the next top card of the deck of the bottom of the deck. If there is okay. Basically, is that you have, for example, one deck of cards, and the idea is take the first, show the value of the card, for example 5, leave this card, and the next card in the top in the deck move to the bottom, yeah, and next again reveal the card left, and the next is put in the bottom. This until reach, not until reach, this you need to repeat until don't have more cards, yeah. Now for this I remember that I have da, 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 17, yeah, for example this here. Okay, the one possible solution for this problem is basically replicate the behavior that mentioned in the descriptions. Yeah, because basically the first hint is that this you need return in increasing order. Yeah, what is the increasing order? If you check here the output is 2, 3, 5. This is the order where is the order what or the order that the cards are revealed. For example, the 2, yeah, the 3, the 5, the 7, the 11, the 13, and 17. Yeah. Now, for this, the first point is that sort these values in increase order, means that 2, 3, 5, 7, 11, 13, 17. Yeah. Now, the next that is create a map. Sorry. Yeah, you need create an array here. 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. Yeah, and create a map. No. Here, let me try to remember. Is attach these values to in the index 0, 3, 5, 7, 11, 13, 17, 3, 4, 5, 6. Yeah, and next to no. This is wrong. We know that how many cards we have. In this case, we have 7. Yeah, is create a queue with this index of these values 0, 1, 2, 3, 4, 5, and 6, and start with this position. For example, the first, this index, the index 0, yeah, this is all other index, yeah, is this value that is is in this position 2. Okay, this is removed and this is moved to the final. Yeah, we will put here Now for this is 2, that is 0 1 2 is this. 2, that is 5, if is in this position here. This is removed and this is moved to the last. Yeah. Now in this slot is index 4 is 11 here. This is removed and this is moved to the last. Yeah. Now for this slot is the index 6, that is 17. The 6 is removed and this is moved to the last. Now the next dot is here, is the value of 3. This is removed and this is moved to the last. Yeah, this is moved to the last here. Yeah. Now in this position is the 1 and this is the 5. Yeah, and let me check. 2 5. No. I think I have the right algorithm, but this is more the value of 2. Why appear the 5 2 times? No, I do something wrong. 2 3 5 7 11 13 17. Okay, and we have a Q here, 0 0 1 2 3 4 5 6. Yeah, and we have here the answer 1 2 3 4 5 6 0. Well, this don't need any value. For this is basically the index 0, that the index 0 is this. The 2. The 2, that is this. This is removed and this is moved to the last. Now the next dot is the index 2, that is 5. 5 is here, this is removed and this is moved to the last. Now for the next dot is the 4. 4 is 11. 11 is put here. This removed and this moved to the last. Now the next dot is the 6. The 17. This is removed and this is moved to the last. This is wrong. Okay, yeah. My bad is that I am handling this 13 as a 2 numbers. Yeah. And here is 1 2 in this case the first time the 0, this is 2, yeah, this is removed, this move to the last. Now the next that is the 2, that is 5, this is removed and this is moved to the last. Now for this slot is the index 4, that is 11, yeah, this is removed and this is moved to the last. No, I was right. Now the next that is the 6, 17, and this is moved to the last. Now the next that is the 3, 7, and this is moved to the last, sorry, to the last. Now the next that is the 1, that is 3, and the 5 is 13. What is wrong? The output should be 2, 13, 3, 11, 5, 17. No, I remember that I did the same mistake when I am using the cues. I forget that is happen. Yeah, in this case is we have this, now we have this 2, 3, 4, 5, 6. We are here and basically is okay, 0, 2, 3, 4, 5, 6, and is take this element that is the 0, put the value here, okay, this is complete, and this is remove it and append and add in the last because it's a queue. In here is the index, yeah, 0, 1, 2, 3, 4, 5, 6. In the index 2 is the value of this. Remove it and this move to the last. Now the next set is the 4. Here is 11, that is this. And this is removed and this is moved to the last. Now the next set is the 6, that is 17. This is moved to the last. Now the next that is the 3, that is 7, in the position 3, 7. It is moved to the last. 1, that is 3. No, I am only do again the sort. No, I am forgetting something here. What is because we mapping the values, we are replicating this. Reveal the card. And the order of this is this. And we start with this. To the final is deck in the index 0, and this is moved to the last. Now index 2, 0, 1, 2. I am forgetting something here because it's in the last, and the next two is this. Please remove it. This in the index, the deck 0, 1 is this. In the position 1 here. This is moved to the last. The index 4 is 11. And this is moved to the last. Now the next dot is the 6, that is this 17, and this is moved to the last. Now the next dot is the 3, that is 7, and this moved to the last. And this is 1, and the next is 13. No, I am forgetting something. Okay, we have 0, 1, 2, 3, 4, 5, 6. Should be 2. I am forgetting something, but I don't remember. What is the Twitch here? problem you have the deck. If you sort these values in increase order, you have 2, 3, 5, 7, 11, 13, and 17. And it's basically take the first, remove this input in the last, but the first is 0, that is the 2. The next 2 should be, the one is moved to the last, the next in the front is the 2. But if we sort these values, the 2 is this, but in this case appear this. Why? I am forgetting something, but I really don't remember. But it's great because this is the idea. Don't remember only the solution, it's more understand the solution. And I am trying to understand in this case, but I don't know if I need use these variables or this index, or is 0, well, this index over the original deck. No. Yeah, because on the final return this and this is wrong. Two, 5, 5 and 11, 17 and 7. This is 3 and 13. It's here. I think that is the way. No, it's in the positive way. If I start with the first, that is 17. 17. Here, that is 17. No. I am thinking that maybe the mistake is here. Okay, let me do again. You sort this value increase order 2, 3, 5, 7, 11, 13, and 17, and you have a queue that is 0, 1, 2, 3, 4, 5, 6. I was thinking that doing the opposite way, start with 6, 5, 4, 3, 2, 1, 0, but it doesn't make sense because the first should be this, and this in the first position is wrong because the first position is the 2. Yeah, this reason I abort this operation, but now it's okay. This is an index. No, I got it. You have, for example, this. This is the result. 1, 2, 3, 4, 5, 6, 7. And basically, the index of 2 is this. Yeah. For example, the 2 is in the index. Yeah. This is remove it, and this is moved to the last. Okay. Let me remove this. Now the next dot is in the index 2. No, here. The index 2 is this number. Here, but no, it's wrong. But here is the same, is wrong because should be the 3. Okay, again. 0, 1, 2, 3, 4, 5, and 6. And the first element, we are moving over this element. The first element is in the index 0. Okay? This is move and this move to the last. Now, the 3 is in the index 2. 0, 1, 2. Okay. Let's remove it. And this is moved to the last. Now the 5, it's in the index 3. Here. This is removed. And this moved to the last. The next element is the 7. The 7 is in the index 5. And this is moved to the last. Oh. Yeah, now the next dot is 11, is in the index 1. This is removed and this is moved to the last. Now the next is this is in the index 4. And this moved to the last. The next why appear here? This is wrong. Okay, we have a list. 6, and this list sorted in increase order. Yeah, and we have all result. Yeah, and is basically okay. The first element should be got in the index 0, like this. This is cancelled and this is moved to the last. Okay, now the 3 is in the index 2. 0, 1, 2, 3, 4, 5. Yeah, the 3 in the index 2. 3 and this moved to the last. Now the value 5, it's in the index 4. Here. And this moved to the last. The 7 is in the index 6. No. What is wrong? Sorry, I am confused. This is this element. Sorry. I will do again. Okay, again. This value sort is 2, 3, 5, 7, 11, 13, 17. and we have a queue that 0, 1, 2, 3, 4, 5, and 6, and this is our result. Okay, and is the first element, it's in the index 0, is remove this element, here is put, and this is moved to the last. Erase. Okay, this is remove it, and this is remove it. Yeah, now the next that is the 3 is in the index 2. 1, 2, 3, 4, 5, 6. Okay, the 3 is in the index 2. Okay, the 3 is here, and we remove this, and this is moved to the last. Okay. Okay, now the next, the 5 is in the index 4. The 5 is here, this is remove, and this is moved to the final. The 5 is in the final. Okay, now the next, this 7 is in the index 6. 7, and this is removed, and this is moved to the final, the one in the final. Okay, now the next that the 11 in the index 3. This remove it, and this is moved to the final. Now the next is 13 is in the index 1. Is remove it, and the last is this element that is 17. Yeah. Now the code for this problem one moment. Okay, sorry, I'll be back. I needed to respond something. Well, now for the solution for this is basically use the queues for have this behavior. Okay, now the next that is create a queue. That this queue is the integers because it is basically the index. It's equal new linked list. Yeah, and next to is a for that integer e it's equal 0, meanwhile I it's minor 2 dec.length I plus plus. Yeah, and here is q.add and is the I. Okay, and next to is erase.sort and is sort the deck. Okay, now the next stat is apply a for. No, it's not a for, it's a while, or it's a for when the no could be the queue. Yeah, and we need to declare here the result. It's equal new int dec dot length. Yeah, and here is basically result in the index. No, this is a for. That for each the result we have the Q, and is the Q I confuse these pointers. Again, here you have this. You have this array sorted is 2, 3, 5, 7, 11, 13, and 17. And you have a queue with these values, and basically is 0, 1, 2, 3, 4, 5, and 6 is the dec in the index 0, it's equal this is the first position is 2, it is moved to the last, and now is the dec in the index 2, 0, 1, 2, no, is in the index 2 is the next element in the index 2 is the next element index 2 is the next element here is 3. I think that it is moved to the last. Now the next that is this. I think that we can for transversal this array integer n dec, and here is result in the index q dot remove, it's equal n, and q dot add q dot remove, and this is return result. No such element, remove first. We need to validate that integer index is equal okay, and it's removed, but this happen only when the queue is not empty. Let's remove first. Yeah, I think that if queue is empty. This is not empty. Mm-hmm. And I need check the a few tests. Okay, I think that works. But I will not submit this code because basically recently I learned how resolve. But again, it's the same case. I will try in a few days or in a few weeks for only for confirm that really understand the question and is not using and it's not only my memory that is resolve this problem. Yeah, but well, I will finish this transmission and I will continue in another one.